Hey everyone, and welcome back to the channel. So I've been away for the summer holiday and I'm going to get back into doing these questions and making these videos. So thanks for being patient with me. And yeah, let's start with this one. So I did this question with one of my students and we found it quite challenging. This was one of the last questions in a UKMT Maths Challenge paper. And I think this is one of the hardest ones I've seen in quite a few years. Okay, let's have a read of this one together. So 5 line segments of length 2, 2, 2, 1 and 3 connect 2 corners of a square as shown in the diagram, like this. What is the shaded area? Okay, very hard question. If you want to, pause the video and have a go at it yourself, then unpause and we'll have a go at it together. Okay. So when I see this question, I first want to make my own diagram. So I'll do that now. So we've got this diagram here, and we can label some of the lengths. So this length is 2, this is 2, this is 2, this length is 1, and this length is 3. Okay, but where do we go from there? So we need some sort of light bulb moment, some sort of eureka moment to help us further. And the big thing I kind of see in this is that this line is going to be parallel to this line, right? Since all of these angles here are right angles, we can see that this line here will be parallel to this line here. What happens when we continue this line? Well, if we continue it, it will come up over here. Okay, and what happens if we continue this line? We can see that it goes all the way over here. Okay. So we sort of got this diagonal strip that goes through the middle here. Okay. We need to sort of think, okay, how are we going to end up with this area at the end of our question? Well, we can sort of make shapes and add those shapes together to form the area. So yeah, the next big eureka moment I sort of can see here is I need to try and split this square in half. And I think a good way of doing it is to form a midpoint of the square. Let's say that's here. Okay. Now go with me here for a second. What if we connect this line over to the midpoint? And what if we continue that line? Well, if we continue that line, it's going to connect here, which is at a distance of 2 from here to here. Okay? Since the distance from here to here is 2, if we continue this line and connect it to this line, this length must also be 2, due to the symmetry of the question. This is useful because if I knew the area of the whole square, then the area of half of the square would be this shape here. And then I would just need to subtract the area of this triangle and the area of this rectangle, and then I would have the area of the shaded region. Okay. Now some of those things are quite easy to find. For example, what is the area of this little rectangle here? Well, it's 2 times 1. So the area of that little rectangle is 2. What about of this triangle? Well, this length here is 2. This length here is 1, since we split this line into a length of 1 and a length of 2. So this length is 3, and this length here is going to be 1. Therefore, the area of this triangle will be 3 times 1, and then divided by 2 to get 3 over 2, or let's just call it 1.5. Cool. So what we're saying is, if we have half of the area of the square, and we subtract 2, and we subtract 1.5, then that would be the area of our shaded region. Okay, now the tough part is, what is the area of half of the square? Well, the big problem we have is that we don't know what these lengths of our square are. So that's going to be our big challenge. What if we draw a line from the corner of our square to the midpoint of our square? So let me just rub out these numbers so they're not in the way. So what if we drew a line from here all the way to the center of the square? Well, that would be half of the diagonal of the square. Okay, let's redraw that triangle below. So it's going to look like this, and we're trying to find this length here. We know what this length here is. It's 2, so we can just put that in straight away. What is the length of this? Well, we can find this length by redrawing this triangle, which is a right angle triangle, where this length here is 1, and this length here is 3. Okay, what is the length of the full diagonal of that triangle? Well, we can use Pythagoras since it's a right angle triangle. So the square root of 3 squared plus 1 squared, which is root 10. Therefore, this length, which is half of this diagonal, is going to be root 10 over 2. Cool. So we've got this length and we've got this length for our triangle, and we're trying to find this length. So far we don't have enough information. What if I were to know this angle here? If I knew this angle, then we could use the cosine rule to get this length. Okay, problem is I don't know what that angle is. Can we try and figure it out? If you look on the diagram here for this triangle, this angle here is comprised of a right angle and this angle here, which is this angle on our right angled triangle. So let's call this angle here theta and this angle here alpha. Well then alpha equals theta plus 90 degrees. Okay. We can use SOHCAHTOA on this right angled triangle to form some identities. So sine theta equals opposite over hypotenuse, so 3 over root 10. Cos theta equals adjacent over hypotenuse, which is 1 over root 10. I think these will be very useful for us. Okay. Now, to use the cosine rule for this triangle, I need to know what cos alpha is. Okay? And cos alpha, we can swap this alpha for theta plus 90. Cool. Now I can use the addition formulas for cosine. So using those, this is equivalent to cos theta cos 90 minus sine theta sine 90. Cool. What does cos 90 equal? Cos 90 equals 0, so this gets cancelled out. Sine 90, what does that equal? That equals 1. So we're left with minus sine theta. And we know what sine theta is. It's 3 over root 10. So we have minus 3 over root 10 for what cos alpha equals. Very good. So now we can use the cosine rule for this triangle to get this length. So let's call this length A. So using the cosine rule, A squared equals 2 squared plus root 10 over 2 squared minus 2 to root 10 over 2. Cos alpha, which is equal to minus 3 over root 10. Cool. Now all we need to do is simplify the right hand side. So 2 squared is 4, root 10 squared is 10, over 4, so let's just call that 5 over 2. Now here, this 2 and this 2 will cancel, and this root 10 cancels with this root 10 here. So we're actually left with minus 2 times by minus 3, and that equals plus 6. Cool. So a squared equals 4 plus 6 is 10. And then we can simplify this right hand side to get a squared equals 25 over 2. Cool. Therefore a equals 5 over root 2. Very good. So far we have found that half of the diagonal of the square is 5 over root 2. Cool. I'm just going to rub out this space here so we can continue. Okay, let's double that. So 5 over root 2 times 2 equals 10 over root 2. So that is the length of the entire diagonal for our square. So let's just draw that to the side here. This is 10 over root 2. And we need to know the side length. Well, we know for this right angle triangle here, these side lengths will be equivalent to each other because they're sides of a square. And then we can do Pythagoras theorem again. So x squared plus x squared equals 10 over root 2 all squared, which is 100 over 2. So x squared is going to equal 100 over 2, then divided by 2, which is going to be 25, and x equals 5. Cool. So we have just found that the side lengths of the big square are 5. So now we're nearly done with the question. If we scroll back up, we look at this expression we made for the area of the shaded region. Now we just need to input the area of the square, which is going to be 5 squared. Cool. So let's just rub out our triangle here. So it's going to be half of 5 squared minus 2 minus 1.5, which equals 25 over 2 minus 2 minus 3 over 2. Okay, what does that equal? That equals 9. So 9 is the area of the shaded region. And that is one of our answers. So we'll circle that and we're done with the question. Okay, very hard question, but a very enjoyable one. There's like a few big key moments doing that question. First big moment is to realize that on this square, this line here is going to be parallel to this line here, right? So we sort of continued those lines to create this segment, which is a parallelogram. Since this line and this line are parallel to each other, this line and this line are parallel to each other. Cool. The next key thing was, how are we going to construct this shaded area? Because it's a weird shape, it's an irregular shape. So my idea was, okay, let's create this line to connect this line and this line. And that will be half of the area of the square. And then we just need to subtract the area of this rectangle and the area of this triangle we created. Cool. And then the third big key moment was to think about how would we find the length of one of the sides of the square. To do that, we needed to find the length of the diagonal. And we were able to construct this triangle here, where A, this length, was half of the diagonal of the square. Then we just had to do some trigonometry, and we were able to find the length of that diagonal. And then the rest of the question was quite easy from there. Cool, I hope you enjoyed and I hope you followed along. I'll be making some more Maths Challenge videos and I'll be posting them up online on YouTube. So yeah, I hope you guys enjoyed and I'll see you in the next video. Bye bye.